Building Information Modeling, BIM, is a digital representation of the physical and functional characteristics of a facility. A BIM is a shared knowledge resource for information about a facility, forming a reliable basis for decisions during its life cycle. Models created using BIM represent more than geometrical data. They are used to include information about aspects of the projects, such as construction materials, their properties and origin, schedule constraints, costs, or even the life cycle management information of a project. The Olympic Stadium in Baku is a prime example of the benefits of using BIM, able to showcase the speed and design quality of a desired project at every level of its development. With a capacity of 68,000 spectators and a total site area of 496,000 square meters, the Baku Olympic Stadium is planned to open in 2015 and will host the inaugural edition of the European Games, a new multi-sport event for European athletes. The Olympic Stadium of Baku is currently being constructed by the Turkish general contractor Tekfen Construction and Installation Company under the funding of SOCAR, the state oil company of Azerbaijan. Hayarim Architects and Planners Company Limited from Seoul in Korea carried out the architectural design, and Thornton Tomasetti from New York in the USA carried out the structural design. SD Engineering from Volos in Greece and Tekfen Engineering from Istanbul in Turkey carried out the detailed engineering, 3D modeling, and BIM coordination. From the kickoff meeting in Tekfen's offices in Istanbul, it was clear to all participants that the only way to achieve maximum team-working efficiency in such a limited time would be the implementation of BIM. This decision was taken having in mind the geographical diversity of key participants and their previous experience in sharing data through different software platforms. Using this kind of technology, operated only by engineers instead of CAD technicians, proved to be a very successful decision for the progress of the project. In total, it was estimated that the time saved was more than 70% in comparison with the conventional CAD strategy. The preliminary BIM included all concrete, precast, and steel members and was used to exchange data with analysis engineering software SAP 2000 for the roof installation verification. While the 3D modeling was developing, a detailed 3D volume geometry of members was exported to 3D FEM analysis software. This data was used for the verification of the plates, profiles, and welding of the complex pinned steel joints. To perform kinetic tests and animate the complex installation procedure, the Autodesk 3ds Max platform was used. The limitations of internet connections proved that real-time or even everyday data sharing was not realistic. As a result, the optimum solution found was to share files once a week, Friday upload, Monday download. This procedure operated via a dedicated FTP server for the first 4 months, and after that period, twice a month. While the Tekla structures team in Volos was updating the total BIM with structural steel data, at the same time the team in Istanbul was updating the total BIM with in situ concrete and precast data. In addition, the Revit team in Istanbul was responsible for updating the total BIM with architectural and mechanical data. When construction started and models were also shared with the general contractor, the teams were rescheduled to support more tasks, such as production of a continuous flow of fabrication drawings, MTO lists, and automatic scheduling via the project portfolio management software. As the BIM was upgrading with more details, the participants could solve complex issues in models that would have resulted in significant delays and confusion to the production chain if they had been solved on site. From the preliminary BIM, all major structural members were attached to attributes that described the estimated time deliveries. Although the contractor's fabrication facility in Ceyhan, Turkey, did not operate adequate ERP software to take advantage of these 4D preliminary data, the data were transferred to Revit and then to Primavera Project Portfolio Management. This procedure allowed the creation of a realistic animation of the construction sequence and accurate definition of the project's milestones. Using BIM in a project of the size and complexity of the Baku Olympic Stadium requires a new step of trust and reliability among the participants. Traditional time schedules and emails are replaced by models that show a clear view of all participants' work progress. This new, true relationship requires careful planning and the willingness of all participants to accommodate each other's needs. Upfront investment in training and time will show the beneficial results later. The success of using BIM for the Baku Olympic Stadium by SD Engineering and Tekfen Engineering won global recognition, as awarded by public vote in the Global BIM Awards of 2013 in the category of Total BIM. The ceremony was held in Berlin in February of 2014 during the Tekla European Forum 2014, where Sofia Sari accepted the award on behalf of the two companies.